Morning 6. Welcome back to another lesson in math. Hopefully you're done with the quiz and everything that went along with it. Let's see how you did. On the front side, you were reducing fractions for the first time. So dividing the top and the bottom by the same number. The answers read like this: 1/2, 1/4, 3/4, 2/3, 1/10. Next row: 1/2, 1/5, 1/4, 3/5, 3/4. Third row: 2/3, 9/10, 1/2, 3/4, 1/4. Final row: 2/5, 2/3, 3/4, 1/3, and 3/5. The mental math section would have went like this. You added, you got $7.25. You multiplied, add a zero on there, you got $3.60. Subtracted, 68 cents. Multiplication, 215. Now guys, what they're really hoping you do with that one mentally is instead of doing 43 times 5, you do 40 times 5 in your head. 40 times 5 is 200. 3 times 5 is 15. Put them together to get 215. Some of you might say it might be faster just to write it out. Great, but remember, that's a mental math section. We're trying to learn to do all A through H right up in our head. E is 500. F, multiply the tops and the bottoms, you get 3/8. Letter next to a number means multiply, so 6 times 7 is 42. H, multiply 100, minus 10 is 90, divided by 10 is 9, plus 1 is 10, minus 10 is 0. Times 10 is 0, plus 10 is 10. 10 divided by 10 is 1. Problem solving, the card shown is rotated 90 degrees clockwise 3 times. Draw the card with the triangle in the correct position with each turn. Now 6, they're going to start to teach you how to visualize things, and I hope you can do that. Your other choice is you have to do what I did, and you'd have to literally draw the triangle and then spin the thing so that you can do it. Both are a possibility. So I started with this thing that looks like this, and I turned it 90 degrees, so it's now going to look like this. I turned it 90 degrees more, that's upside down, and I turned it 90 degrees more, and it's now pointing to the left. So 1, 2, 3, as I did that thing. If not, you got to get to what I did, take the time to draw it, and then spin, 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 spin to be able to get your answers. Okay, yesterday guys, we were working with perimeter. Our lesson was like 2 sentences, perimeter, add the distance around, and we got a bunch of problems. Today, much longer lesson, 3 different parts to it as we get rolling on this. We're going to go from perimeter yesterday and add area to it today, along with a couple extra concepts with exponents and square roots. Those are like inverse operations of each other. Exponents, squaring a number by itself. Square root is the exact opposite of it. Hopefully you have your yellow folder out, and we'll get ready to get rolling with it. The lesson reads like this. We remember that we can show repeated addition by using multiplication. So 5 plus 5 plus 5 plus 5 is the same as 4 times 5. There's also a way to show repeated multiplication. We can show repeated multiplication by using an exponent. 5 times 5 times 5 times 5 is 5 to the 4th power. In the expression 5 to the 4th, the exponent is 4, the base is 5. The exponent shows how many times the base is to be used as a factor. So then they have the base and they have the exponent. The following examples show how we read expressions with exponents, which we call exponential expressions. 4 squared, or 4 to the 2nd power. 2 cubed, or 2 to the 3rd power. 5 to the 4th power, 10 to the 5th power. To find the value of an expression with an exponent, we use the base as the factor, the number of times shown by the exponent. So 5 to the 4th power is 5 times 5 times 5 times 5, which is 625. So we have special ways of saying it for the 2 and the 3. That's squared and that's cubed. Everything else is just the number to the whatever power they give you. In our book, we won't get too big of powers that they make you work through. They'll actually keep it usually in squareds and cubes. The only time they'll give you bigger numbers is when it's with 10, and that's pretty easy to go along with that. All right, let's check our yellow folder to see how we're doing with that. We had exponent, number of times to multiply the base. The base is the number being multiplied. Exponential expression, obviously, are expressions that have exponents. Okay, so you got your blank filled in with exponents. Let's work a few. Remember, we work those examples on the bottom of our power up sheet right here, guys. So write down here with me, example 1, A, B, C, D, and be showing your work so that I know that you are understanding what's going on. Number 1 says, please simplify these. In other words, give us the answer. This is not 4 times 2 is 8. This is 4 times itself 2 times. So 4 times 4 is 16. This is not 2 times 3, it's 2 times 2 times 2. So 2 times itself 3 times. 2 times 2 is 4. 2 times 4 times 2 is 8. 10 times 5, guys, is 10 times 10 times 10 times 10 times 10. Easiest way to do this is your exponent tells you how many zeros there are. So 1, 1, 2, 3, 4, 5. 100,000. Okay? Those of you who can see up here on the board, 100,000 is 10 to the 5th power. But when they give bigger exponents with 10, it's just how many zeros are in the number. 2/3, we now have a fraction. When we have a fraction, we do the exponent to both the top and the bottom. So 2 squared is 4, 3 squared is 9. So just take your exponent to the numerator and the denominator. Example 2 says, can you simplify this problem? So I have 4 squared minus 2 cubed. Looks like I forgot to write that one on the board. So I have 4 squared, 16, minus 2 cubed. I subtract 16 minus 8, and I get an answer of 8. Okay, so they'll just put that into math problems for you guys. Example 3 says, find the missing exponent in each equation. They're going to teach you a truth, guys, that we're going to get later on in this book, but we're going to learn the truth right now. The first one is 2 cubed times 2 cubed, so I wrote it out. What is this? This is 2 3 times. This is 2 3 times. So I'm really doing 2 6 times. So my answer is 2 to the 6th power. The n equals 6. Now, what's the truth you want to learn? Anytime the bases are the same and I'm multiplying, I just add the exponents. 3 plus 3 is 6. Well, if I add the exponents when I'm multiplying, you can probably guess what you're supposed to do when you're dividing it. You do the opposite. I wrote it out for you. 2 times 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2. Now, guys, we've been practicing canceling fractions. Whatever's on the top is also on the bottom. You can cross them out. So what am I left with on the top? 3 of them. What's 6 minus 3? 3. So this is 2 to the 3rd power. When I'm dividing exponents, I simply subtract the exponents to get an answer. Now, you got to be careful because the division makes me think I should divide those or I should multiply those. No, not with the exponents. When you're multiplying, you add. When you're dividing, you subtract. Okay. Now 6, they got a big, huge, long lesson about finding the area. It says we can use exponents to indicate units that have been multiplied. Recall that when we add or subtract measures like this, the units do not change. So 8 feet plus 4 feet plus 8 feet is 12 feet. However, when we multiply or divide measurements, the units do change. The result of multiplying feet by feet is getting square feet, which we abbreviate square feet or feet squared. Square feet are units that we use to measure area. We see this in the next section of this lesson. Okay, now they're going to teach you how to do area. The diagram below represents the floor of a hallway that has been covered with square tiles that are 1 foot on each side. How many 1-foot square tiles does it take to cover the area of the floorway? We see that there are 4 rows and 8 tiles in each row, so there are 32 1-foot squares. It's an equal group problem, guys, straight up multiplication. The floor tiles cover the area of the hallway. Area is the amount of surface. Floors, ceilings, walls, sheets of paper, polygons all have areas. If a square is 1 foot on each side, it's a square foot. Thus, the area of the hallway is 32 square feet. Other standard square units in the U.S. system include square inches, square yards, and square miles. It's important to distinguish between a unit of length and a unit of area. Units of length, such as inches and feet, are used to measure distances, not measuring areas. To measure area, we use units that occupy area. Square inches and square feet occupy area and are used to measure those. Okay? On the top of page 137, underneath the box, it says one way to find area of a rectangle hallway is to count the tiles. What is another way to find it? Creating the formula for areas of a rectangle, it says length times width would give you the area. Or what would we do for area of a square? The sides are the same, so it would be s squared to find the area. So guys, area is a kind of a review lesson. You've had it in previous years. To find area of a rectangle, you multiply length times width to find area of a square. The numbers are the same, so you just take that side and square it. So it says, what's the area of this rectangle? 5 times 3, I multiply, and I get 15. Now we got to have the label, and they're working in inches, so it's 15 square inches. Because I'm taking the inch times the inch. How many inches do you have? You have 2 of them, so it's inches squared or square inches. Write it either way, not both, obviously. That was not how you do it. Okay, so it's a multiplication problem. Now, example 5. The perimeter of a certain square is 12 inches. What's the area of that square? So that's going to yesterday's lesson. I knew the perimeter was 12. So what's the length of one side? How many sides on a square? 4. So I take 12, I divide it by 4, and I get 3. So this is 3, 3, 3, and 3. Area is S squared. So stick my number in. For the S, area is 3 squared, and 3 squared is 9. And we were working in example number 5 in inches, so it's 9 inches squared, or square inches. Number 6, Dickerson Ranch is a level plot of land 4 miles square. The area of its ranch is how many square miles? So I got a square. I simply take 4 times 4 and get 16 miles squared. And then the last part of our lesson. To summarize, if we multiply 2 perpendicular lengths, the product of the area of the rectangle, for squares with perpendicular lengths are called sides. For other rectangles, they're called length and width. Thus, we have these formulas for area of squares and rectangles. The area of the square is side times side, which is A equals S squared. The area of the rectangle is length times width, so it's A equals LW. So just have those formulas down, guys. I put those into your yellow folder. Make sure you have them memorized. Last part of our lesson, the area of a square and the length of its side are related by squaring. If we know the length of a side of a square, we square the length to find the area. So this 3 by 3 square illustrates that 3 squared equals 9. If we know the area of a square, we can find the length of a side by finding the square root of the area. We often indicate square root with the radical symbol that looks like a check mark with a box over it. When you take these quizzes from me, guys, it'll look like just a check mark. So if they have that nice thing like that, and my computer is just like this, and you'll see like the 9 next to it. That says take the square root of 9. Okay, I just turned my page by accident. Sorry about that. Hang on. This illustrates that the square root of 9 is 3, which we read as the square root of 9 equals 3. So simplify. So I got these last 2 problems over here, guys, where I have the square root of 121. This is where we've been working hard of, hey, you got to know your perfect squares. 1, 4, 9, 16, 25, 36, those things. Guys, this is where it comes in. So what's going to give me 121? What times itself is 121? There's no shortcut to this, guys. You just got to memorize it. It's 11. I know that 10 times 10 is 100, so I just go up a little bit bigger from that. Then this last one is also teaching you a truth. What's the square root of 8 squared? Okay, well, I first have to do 8 squared. What's 8 squared? That's 64. What's the square root of 64? That's 8. What number times itself gives me 64 is 8. So if you look at that, guys, you can see what the square and the square root do. They ask you that question just so that you can do this. Hey, I can just cancel those 2 things out. Squares and square roots cancel each other. Now that works, guys, when they're just doing it to the one number. Sometimes they'll give you math problems, like take 5 plus 7, then square it. That is going to give us something different. But squares and square roots, guys, cancel each other out. So that's a slight shortcut for you to be able to do those things. Okay, hopefully you have that written down on the back side of your Power-Up quiz. Now you're going to get out your other piece of math paper, your answer key, and we'll get ready to work some math problems. 6th grade, here we go. Lesson 20, starting to rock some problems. Number 2 says the candidate for the U.S. Senate from Arkansas wants to visit every county in Arkansas. She has already traveled to 36. She has 39 left. How many counties are in there? So she did 36. She still has to do 39 to give me a grand total of adding those together. That gives me 15. Carry the 1, 3 is 7. There are 75 counties, not countries, counties in Arkansas. Number 4, choose the formula for area of a square. Guys, that's right out of your assignment today. Number 1, it's letter C. Number 2, it has to be letter C because it's the only one that has the word area in it. So area of a square is area equals S squared. Number 5, the rule of the following is K equals 2 to the n. K equals 2 to the nth power. Find the 6th term in the sequence. So I got to take 2 times itself 6 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Might have been easier to group them like this. 2 times 2 times 2 is 8. And that's 8, and 8 times 8 is 64. Number 7, Which is the best estimate of how much the rectangle is shaded? So I look at that thing, guys, and I say it's definitely less than half. So A is gone. D is gone. That's more than a half. Now I got to decide between B and C, and I'm looking, B is 1/3 and C is 1/4. I'm going to say the answer would be B. It looks more like a 1/3 to me than it does a 1/4. Number 11. List the factors of each number. So first of all, the factors of 10. 1, 2, 2 goes with 5, 1 goes with 10. Now I'm listing the factors of 7. 7 goes with a 1 and a 7. And the factors of 1 is just 1. Number 12. The perimeter of a certain square is 2 feet. How many inches long is each side of the square? Look what they're doing to us already with that question. I love it. So the perimeter is 2 feet. I'm going to switch that to inches. Perimeter of a square, there are 12 feet in an inch, so 12 times 2 is 24 inches. Then I have a square, guys, and how many sides are on a square? 4. So I take my 24-inch perimeter, and I divide it by 4, and I get 6. So the side is 6 inches. Great problem. So make sure we read it carefully and see that we switch from feet to inches. Number 13, write a squaring fact and square root fact to illustrate this. Okay, we're going to get this on our test coming up too, guys. So what is this square? That tells me I'm doing 6 by 6. A squaring fact is 6 squared is 36. What's the square root fact? That's the opposite. The square root of 36 is back to 6. So you got to know that's kind of like a fact family, but not as many, guys. So make sure you understand that. You'll have it on your test coming up. 14. What's the probability of rolling an even number with one roll of the cube? Well, I know there's 2, I know there's 4, and I know there's 6. That's a total of 3. I know there's a total of 6 numbers on the cube, so it's 3 6. I gotta divide both those numbers by 3 and get 1/2. So you're practicing probability with reducing. Flipping your answer key over, you're up to number 17. 17, they gave me 5 to the 4th times 5 squared equals, remember when I'm multiplying, I add the exponents. That's 5 to the 6th power. Number 18, I'm missing the divisor. I still divide. 4 goes into 6 once, subtract 20, goes in there 5 times. I have an answer of 15. Number 20, I have 5 times 2 over, 5 over 2 times 5 over 6. Multiply the tops, 25. Multiply the bottoms, 12. Now I'm doing division. How many times does 12 go into 25? 2 times. 2 times 12 is 24. 24 minus 25, 25 minus 24 is 1. 12 left over. If you don't do that, guys, in your head, then be willing to pay the price. Top number in the box, bottom number outside the box. And by the time I said all that, you could have written the problem, guys. It goes about it just as fast. 22, big multiplication problem. I have 360 times 25. Many will just put that 0 straight down. That's fine by me. It doesn't matter to me either way. I'm going to do 25 times 36. So I'm going to do 30, carry the 3. 15 is 18. Add a 0. Here I go. 2 times 6 is 12. Carry the 1. 3 times 2 plus 1 is 7. Now I bring that 0 straight down. Got 0, 10, carried 9. I have an answer of 9,000. 24 has 3/4 minus 1/4. That would equal 2/4. I know you can reduce that, guys, but I'm not going to because I have to add it to 2/4. So now 2 plus 2 is 4. The bottoms stay the same, so that equals 4/4. 4/4 over each other equals 1. 27. Write 1 4/5 as an improper. Multiply, add. That gives me 9 over 5. Then multiply the improper fraction by 1/3. Okay, so you could cancel the 3. Divide by 3 here. 3 divided by 3 is 1. 9 divided by 3 is 3. That's canceling. That gives me multiply the tops, 3. Multiply the bottoms, 5. And last, turning the page in my math book, 29, says a common floor tile is 12 inches square. What's the perimeter and what's the area? So you have a tile that is 12 inches by 12 inches. To find the perimeter, I take 1, 2, 3, 4 of them times 12 and get 48 inches. To find the area, I take 12 times 12. Hopefully you have that memorized, guys. That's a perfect square. That's 144 square inches. Perimeter, area.